Okay, Unit 12, Section 2, mean and standard deviation. First of all, let's go through a little bit of notation so we can kind of all be on the same page when you get these formulas thrown at you. But to find mean, which is the same mean as you would have done, or the same thing you would have done when you would have found average. So mean is the statistical meaning for average. You have either what's called X bar, or you've got mu. You have either sigma or you've got S. Now, we're only going to use this sigma one. It actually is not the sample standard deviation. It's actually the population standard deviation. All right, so here we go with a couple of formulas. Mean is the average. It kind of tells the middle of the data. Whenever you see this uppercase E, it means to take the sum. So the sum of those values of X divided by the total number that you have. Okay, your standard deviation is really a number that tells how spread out the data is. What that kind of tells you, let's say I've got a standard deviation that is 0. That means all the numbers that went into finding out the average were exactly the same. Now, if that standard deviation is 1, that means maybe they're kind of spread out away, but it still averages out to be the same mean. And maybe you got a standard deviation of, like, say, 15. 15 is a pretty big number, so that means the numbers are kind of scattered all over the place. Okay. We can do these calculations by hand, but it does get to be a lot of work, so we'll end up doing a lot of this with graphing calculators, so that's going to help you out a lot. I'm sure you can find some other program maybe as well. So here is how we read the standard deviation. The size of the standard deviation is relative to the mean, so it's kind of all dependent on what the mean is. For example, if I've got a class average of 75, so that would be my mu, and a standard deviation of 5%, that means that the data is fairly close together compared to this next class. The next class walks away with the same average of 75, but their standard deviation is 25, so that means their data is more spread out. The closer the standard deviation is to 0, the more consistent it is. Okay. So let's try one out by hand. You can take 2, 3, 3, 8, 10, and 10. I'm going to take the numbers right there and just kind of list them out: 2, 3, 3, 8, 10, and 10. I'm going to find the sum of X, which is basically adding all those up. So there's 20, 30, 33. Okay, I got 1, 2, 3, 4, 5, 6 numbers, so N is equal to 6. So I think I might miscount here. Yes, 36. So my average is going to be 36 over 6, or 6. Next thing I'm going to do is I'm going to take these numbers, I'm going to go X minus my average. So 2 minus 6, and I'll get -4. 3 minus 6, I'll get -3. 3 minus 6, -3, and I'll just kind of keep on going here. Now, it's okay that some of these numbers are negative, because my next move is to square them. And I'm kind of running out of room there, but I'm going to take each of those X minus mu numbers, and I'm going to square those. So -4 squared, 16, 9, 9, 4, 16, and 16. Take the sum of those, and I got 16 plus 9 plus 9 plus 4 plus 16 plus 16. So that right there is 70, and that represents the sum of X minus mu squared. So for my standard deviation purposes, I'll take 70 divided by 6, and then take the square root of that. I got the square root of 11.6 repeating. Which is roughly, let's see, 3 point something. Just a second, I'll pull up my calculator here. So take the square root of that, and I got 3.4. I'll go 1, I guess it's 5, so 1, 2. If I round to the nearest hundredth, that should be good enough if you want to round to the nearest hundredth. Now, since the average was 6 and my standard deviation is 3, this probably is telling me that I got numbers all over the place, which they kind of were. I mean, my top number was 10, my bottom number was 2. If you remember range, range is the biggest number minus the smallest number. 10 minus, so range is 10 minus 2 of 8. Okay, 8 can be affected a lot by outliers on either end. Standard deviation is a better way to tell me how spread out that number is. Okay, so here's how you do it in your calculator. Step 1, you're going to get to this screen on your calculator by going to, it's the stat button, and number 1, edit, and then hit enter. Should bring you to that list. You can just type in the number, hit enter, type in the number, hit enter, type in the number, and hit enter. To get to this screen, you're going to go back to that stat menu, but you're going to have to arrow over once, and then you're going to have to hit either the number 1 for 1 var stats, and then hit enter. It should bring 1 var stats up. While 1 var stats is written there on the screen, hit enter again, and those numbers should pull up. If you use your down arrows, you should be able to scroll, and you can scroll up and figure out the average was 6. The sum of x was 36. Your S of x is 3.7, but we're not using that one. We're using the population one of 3.41, which is exactly what we got doing it by hand. Okay, so here you are not going to take 30 numbers and do them by hand. You're going to do them with your calculator. So go back to L1, and you can just enter these in over your previous data. Be careful, like I'd type in 0.54, cross it off, 1.8, cross it off, 1.52, cross it off. Keep on going. Run 1 var stats. Now, the only thing I don't like about 1 var stats is x bar will only show up. That's the same thing as mu. Okay, give you some time, and you can pause this. I'm going to get you your answers right now, but make sure you pause this, go through, do it with your calculator. I got an average of 1.14, and I got a standard deviation of x, which is basically our sigma of 0.806. So TI is our friend when it comes to this, because it can take you a long time to do these off by yourself.